Hello students, good evening. Welcome to another video of Vedantu Karnataka. This is Catherine, your physics master teacher. How are you all doing? Can you quickly let me know in the chats if I'm audible and visible? Hi Kirtana, hi Rakshita. Students, good evening. Hello. Okay, so let's wait for 2 more minutes because our class is supposed to start at 9 o'clock, right? How are you all doing? Are you all done with your first unit test or your FA1? Is physics over? If physics is over, let me know in the chats. How was your physics exam? Will you all get full marks? Quickly, Kirtana, Ashmita, Akshita, quickly send the video to all your class groups. Even if they're a first PU or a second PU student, ask them to join. Because if you are someone preparing for KCET, then this is for you. Okay, so in today's class, we will be doing motion in a straight line. And motion in a straight line, I'm sure all of you have already learned that chapter. So today we will be doing basics of that chapter and past year question papers for KCT. Okay? Is that clear, all of you? So that is what is today's agenda. Students, I already told you in the last class, we have our Mega Vedantu Scholarship Admission Test. Okay, so this is your one and only chance to become a national champion. So all you have to do is you go to our offline center on 4th, 5th, 11th or 12th to write the exam. If you clear the exam well, then you are going to get, up to 100% scholarship on Vedantu courses. Now, if you're lucky enough, you will get, we have 150 crore rupees worth scholarships, rupees 2 crore worth cash prize, and many more. Okay, so make sure you attend to the exam. It's going to be on 4th, 5th, 11th, and 12th of October at our offline center. Now, if you're someone from Karnataka, our offline center is in Bangalore. It's at JP Nagar. Okay? Yes. Hi Tilak, welcome to the lesson. All those who are there in class, can you all say hi? And please go like the video quickly. All of you like the video. Hi Sanjay, good evening. I'm good. How are you? Hello Chetan. Hello Sahana. Okay, are you all ready to learn? Ready? Quickly, all of you go like the video. Let's make it at least 20 likes in today's class. Quickly, let's go like the video. Hello Virat Malu. Yes. Hi Srinu. Hi Sanjana. Hello. Welcome to the lesson. Okay. So since we have enough students in class, let's start. As I already said, Mega Vedantu Scholarship Admission Test. Make sure you write it at our offline centers on 4th, 5th, 11th or 12th. Okay. Ma'am, do you know who I am? I know Sanjay. Tilak. Yeah. Okay. So, motion in a straight line. Okay. Are you all ready to learn motion in a straight line? Yeah. So what is motion? Motion is when something is moving. What is motion in a straight line? Motion along one axis. What is rest? When something is not moving, it's at rest. So if something is not in motion, then it is at rest. But these are topics that are relative to each other. So for example, if you are driving a car, okay, and I'm sitting beside you. Okay, I'll drive the car because I'm older, no? So I'm driving the car, you are sitting beside me. With respect to me, you are at rest, right? Because both of us are sitting inside the car. But if there's someone standing outside, so your mom is standing outside and waving by, with respect to your mom, you are moving, isn't it? So rest and motion are two things that are relative. It depends or varies on whose perspective you look. For example, in when I'm both of us are in the car, both of us are at rest. But when someone from outside looks, both of us are in motion. So depending on the observer, rest and motion can change. Okay? Yes. Is that clear? Now, in this chapter, we are actually going to learn about linear motion, which is motion in one dimension. So there's no jumping up and all. In projectile motion, right? Projectile motion is like you throwing a javelin. So there's the x-axis, y-axis, and z-axis. But in this chapter, we are not going to look at that. We are going to look at bodies that move in only one axis. Okay? So that is why motion in a straight line. So we are going to start by looking at two simple concepts, distance and displacement. Okay, so what is distance? What is displacement? Let's look at that first. What is distance? Distance is the total path, covered by body. For example, imagine your house. Okay, this is your house and this is your friend's house. Okay, that is your house and the other one is your friend's house, and this is the road. Okay, so the amount of distance that you travel is the distance. So what does that mean? It is the path that you take, okay, the amount of time that you take to reach there, and the speed, everything together gives you the distance. So the length that you travel is your distance. Okay, so imagine if this is 5 kilometers, then the distance is 5 kilometers. So if you go to your friend's house, you walk or you drive 5 kilometers. When you come back, you walk or you drive another 5 kilometers. So what is the total distance that you should travel to go to your friend's house and then come back? Quickly tell me. So it's 5 kilometers from your house to your friend's house. So for you to go there and come back, what is the total distance? How much should you travel? Quickly, let me know the answer in the chat. How much should you travel to go to your friend's house and come back? Yes. I don't see any answers in the chat. How much time? How much distance would it take? Yes, very good. So it'll take a total of 10 kilometers. 5 kilometers to reach your friend's house, 5 kilometers to come back. Okay? So that is distance. What is distance? Distance is the total path covered for a body, or it does not depend on direction. It's just there as it is. Okay? Are you all following? Yes. No. Students, is this like a very late time for you? Should I make my class earlier? Yeah? Yes? No? So distance is the total path traveled by an object. So what kind of quantity will distance be? Will it be a scalar quantity or a vector quantity? Obviously, it will be a scalar quantity. Why? Because it does not depend on direction. Even if you go forward or backward, the length that you travel is your distance. It does not depend on direction. Okay? Now, next is displacement. What is displacement? Okay, what is displacement? Now, if the same scenario, so this is your friend in your house and the other one is your friend's house. Okay, so the displacement will be like this. Okay, So the green arrow represents, the green line would represent displacement. So displacement is the shortest possible distance between the two objects. So if you go, take the whole curved path, that is your distance. But the shortest possible distance is your displacement. Okay? Very good, Kushwant Naik. I believe that's your name. Very good. Okay. Super. So displacement is obviously a vector quantity. Why is it a vector quantity? Because it depends on direction. Now, imagine this green line is 2 kilometers long. Okay. So from your house to your friend's house, the displacement is 2 kilometers. So what is the total displacement for you to go to your friend's house and come back? What is the value of total displacement? Can you quickly let me know in the chats how much would the displacement be? So you have to go to your friend's house and then come back. So what will your displacement be? Did you all like the video? It's just 6 likes, students. Quickly. More likes. More power. Yes. So the displacement will be 2 kilometers in the forward direction, which is from your house to your friend's house, and then 2 kilometers back. So it will be -2. This will be 0 kilometers. Why? Because displacement is a vector quantity. So for those of you who didn't understand, if you are standing here, okay, and you move forward, that is positive displacement. Okay. Now from here, if you move backward, then that is negative displacement. Okay. So if you move up, this is positive. If you come down, it is negative. So if you throw a ball and the ball comes down, the total displacement is 0. Okay. So displacement is the shortest possible path. So you can look at it in terms of that also. So it is the shortest possible path that an object would take. Okay. So you are standing here, you go to your friend's house and you come back. What is the shortest possible path that you could have taken? Is to stay at your house. Isn't it? Because anyways, you're coming back to your house. So that is displacement. Okay. So if you move 3 meters forward and 5 meters backward, then the displacement will be the difference. 3 minus 5. Okay. Is that clear, all of you? Yes. Okay. Okay. Let's we'll look at KCET questions. Before that, let's finish these topics. Next is speed and velocity. Okay. What is the difference between speed and velocity? I'm running. Okay. I'm running with a speed. How can I say I'm running with a velocity? What should the difference be? What is the major difference between speed and velocity? I'm sure you have heard both the terms, speed and velocity. But what is the major difference between the two? Huh? What is it? Speed is a scalar quantity. Velocity is a vector quantity. Okay. So speed is basically the amount of distance that you move with respect to time. So if you have a running race from A to B, okay, let's say the distance here is 5 kilometers and you take kilometer per let's say 5 meters, okay, 5 meters, and you take 10 seconds, all right, to cover it. The speed will be what? Speed will be 5 by 10 meters per second. Did you understand? So that's the relationship between speed, distance, and time. Okay. So speed is distance by time, the amount of distance covered in a certain amount of time, and its unit is meter per second. It's a scalar quantity. So even if I'm running in the forward direction or the backward direction or towards east or south or west or north, or if I'm jumping up or coming down, the speed does not change with respect to direction. Okay. Even when you're driving your car, the speedometer shows you the speed. In whichever direction you go, it shows you speed. So it does not depend on direction. Speed is a scalar quantity. On the other hand, what about velocity? So velocity is basically displacement by time. Okay? Velocity is displacement by time. So if I am moving from A to B, if I'm moving in the forward direction, the displacement will be a certain value. If I'm moving in the backward direction, the displacement will change again. So displacement depends on direction. So obviously, velocity should also depend on direction. So it is a vector quantity. It depends on direction. Okay. So if you have cars, imagine you have some cars. Okay, my head is not covering it. Okay. So imagine you have some car. Okay. So this is car A. It's moving like this. Okay. After some time, it comes back. Then it moves like this. Then like this. Then like this. Then like this. Okay. It moves in random direction. Okay. So the total velocity can be zero. If all the directions are there, then the total velocity will be zero. Because the forward direction and the backward direction, what happens? They cancel out. The left and right will cancel out. Side and side will cancel out. Okay. So velocity will all cancel out. But if it is speed, you will just add all of them up. Okay. So if a body moves, okay, now I'll give you a simple question. Let's say there's a track. Okay. Sorry. Okay, this is a running race. Okay. There's a track. And there's a girl standing here. Girl or boy, anybody. Okay. There's a running race. So from here, this person, he will run, 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 and reach back there. Okay. So the track is a 400-meter track. Okay. And the time taken to run this 400-meter is, let's say, 40 seconds. Okay. 40 seconds. Yeah. It takes 40 seconds to run 400 meters. So what will the speed of the girl or boy, whatever speed will be? Distance by time. So which is 400 by 40. So which is 10 meter per second. So everywhere on the track, the speed is 10 meters per second. Yeah. Do you all agree with that? Everywhere on the track, the speed is 10 meters per second. Okay. Any doubts there? Any doubts? Any doubts? Are you all sleeping in class? Okay. Okay. Now, what will my velocity be? What will the velocity be? That's the question. What is the velocity going to be? Velocity is going to be equal to okay, attitude girl. Velocity is going to be equal to displacement by time taken. And what will the displacement be? If a person starts from one point, he gets back to the same point. What is the displacement there? Very good. It's going to be displacement by time. Displacement by time. And it will be displacement by time, and it will be 0 divided by 40, which is going to be 0. Okay. Why is the displacement 0 here? The displacement 0 here is here because he is starting from here, going like this, like this, like this, and coming back. Yeah. So all the directions will cancel out, isn't it? So this is going to be positive, negative, they cancel. Positive, negative, they cancel. So all the displacements will cancel. Velocity is going to be 0. Now, how do I find velocity at each point other than by using this formula? So what I can do is, I can take the tangent at every point. Okay. So if I take this point, the velocity at this point will be like this. Here it 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 will be like this, like this, like this, this. So this is how the velocity will be. So you can see that the velocities also cancel out. So the velocity here and the velocity here will cancel out. The velocity here and the velocity here will cancel out. So you can see this is a symmetric circle, right? It's just two halves. So whatever velocities are there on this side of the circle, all the opposite side velocities will be there on this side. So they cancel out. So in a circular path, velocity is always 0. Displacement is also 0. Okay. Hi Ravi Teja. Hi Attitude Girl. I already said hi. Yeah. Okay. So for velocity, this is a vector quantity. It depends on displacement and direction is essential. Okay. Now there are also two different kinds of speed and velocity. Average speed and average velocity. Instantaneous speed and instantaneous velocity. So what is average speed? Average speed is the average. How do I find average? You take the total distance divided by total time. Average velocity will be what? Total displacement by total time. Now, what is instantaneous speed? Instantaneous speed is the speed at one particular instant. So imagine I'm going for a 1 hour long car ride. At one particular, let's say after 10 minutes, I want to know the speed. So at that particular instant, whatever is the speed, that will be your instantaneous speed. Okay. Or at that particular instant, whatever the velocity, that is going to be instantaneous velocity. Okay. So average speed is the total distance by total time. Average velocity, total displacement by total time. Instantaneous speed is the speed at that one instant. Instantaneous velocity is the velocity at one instant. Now, average speed will always be greater than or equal to average velocity. Why? Because speed and velocity, the only difference is direction. So, velocity can never be greater than speed. Velocity can only be equal to speed. Why? So, let's say car is going from A to B. Okay. Let's say speed is 5 meters per second. Okay. Velocity will also be 5 meters per second because car is going straight. Yeah. Car is going straight. Speed and velocity is going to be the same. Now what happens? Car returns back. From B to A, the car returns back. Okay. Now speed is still 5. But in this case, velocity will be 0 because it's going in the opposite direction. So you can see that the speed is always either equal to velocity or greater than velocity. It can never be the other way around. Okay? Yes? Is that clear? Okay. Now let's look at acceleration. Okay? So we look at the questions at the end. I've put KCET questions here. What is acceleration? Acceleration is the rate of change of velocity with respect to time. So acceleration is rate of change of velocity means what? Final velocity minus initial velocity, the whole divided by time. Final velocity is represented by V. Initial velocity is represented by U. Time is represented by T. Now, since V minus U represents change in velocity, I can write it as del V. Yeah. So, V minus U by T is del V by T. Okay. So, acceleration is what? Change in velocity by time. Change in velocity means final velocity minus initial velocity, which is V minus U. Okay, what is SI unit of acceleration? We can derive it. What is the SI unit of velocity? Velocity is speed by time. Sorry, velocity is displacement by time. Displacement is meter, time is second. So, this is velocity divided by time. Instead of time, I put seconds. Seconds. So, this will be meter per second square. Okay. So, the unit of acceleration is meter per second square. Okay. I'm good, attitude girl. How are you? I'm doing very well. Okay. Okay. Now there are two different kinds of motions, mainly uniform motion and non-uniform motion. Yeah. Motion, I can divide motion into motion can be divided into uniform motion and non-uniform motion. Okay. Uniform motion and non-uniform motion. What is the difference between the two? Uniform motion is what? When the speed is the same. So, if you're driving and you cover equal distance in equal intervals of time, then that is called uniform motion. Okay? But if you cover like initially you're going in very high speed, then you're going very slowly, then you're going a little more high speed. So, your speed keeps on changing. So, you cover different distances in different amount of time. That is called non-uniform motion. Okay? Yes? Okay. So let's say this is A, this is B, okay? And you are driving, okay? Let's say this is you. You're driving. So initially you cover, equal distance in equal amount of time. Then you go very fast. Again you go slowly, then very fast. Slowly, 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 slowly. Then you go very fast. Okay? So that means, oh, I can draw lines. Okay. So that means you in the first let's say 10 meters, you take 10 seconds. Okay. The next 10 meters, let's say you take 20 seconds. So you slowed down. Next 10 meters, you go very fast. You take 30 seconds. And it is just continues like this. So is this kind of motion uniform motion or non-uniform motion? There is a live chat. I can't see the live chat. Okay. So yeah, what is this uniform motion or non-uniform motion? This is non-uniform motion. But imagine every 10 meter, the speed was, every 10 meter, it took 10 seconds. So same speed. Then it is uniform motion. Hey, I like your name. Study with your friend has asked me a doubt. Study with your friend needs to know. Ma'am, can you please explain what is the difference between average speed and average velocity? Of course, I can explain it to you, dear. Average speed and average velocity. So average speed means, okay, imagine from your school, you go to your house, okay, and this is the total distance, okay. So for first 5 kilometers, you took 30 minutes, okay. And then the next 4 kilometers, the next 4 kilometers, you took 20 minutes. And then the next 1 kilometer, you took 2 minutes. Okay. Let me draw the house here. Okay. Okay. Like this. And then the next 30 minutes for the next 3 kilometers. Okay. So imagine this is the way from your school to your house. What is the average speed? The teacher tells you, asks you at what average speed are you going home? So you will say, ma'am, in total I have 9, 10, 12 kilometers. My house is 12 kilometers away and I will take 30, 40, 50, 60, 70, 80 minutes. Okay. I take 80 minutes. So the teacher asks you to find average speed. So what you should do? You should write average speed is equal to the total distance 5 plus 4 plus 3, the whole divided by 30 plus 20 plus 30. Okay. So units and all you should convert. Okay. I'm not doing all that. The idea is simple. And then whatever answer you get, that is your average speed. So how much ever distance you travel and how much ever time you take, the total distance by total time is your average speed. Now what is average velocity? So now you can see here, this 3 kilometer is in another direction. Yeah. 5 and 4 are in one direction. 3 is in another direction. So average velocity will be the total displacement divided by total time. So if it's like a curved path, it's difficult. So let's say like this. Okay. You go like this. So this is going to be 5 kilometer plus 4 kilometer. And then 3 is in another direction. Okay. So for you to understand, I'll give you another example. This will make it very clear to you. Okay, this is your house, okay? Okay. So total distance will be 5 plus 4 plus 3 plus 1 plus 10, okay? Now, average velocity will be how much? What is the total distance here? 5 plus 4 plus 3. But 10, I mean the 1 kilometer is in the opposite direction. Minus 1. The whole divided by 30 plus 20 plus 30 minus 10. Why? Because this is in the forward direction. This is in the backward direction. So there is a difference in direction. So average velocity is total displacement. Displacement depends on direction. Okay. So that's the difference between average speed and average velocity. Average speed is total distance by total time. Average velocity is total displacement by total time. So there the direction is also involved. Are you understanding? Study with your friend. Is this clear to you? Yes. Can you let me know in the chat if this is clear? Quickly, students, is this clear to all of you? Study with your friend. Are you there in class? I don't see a response. Okay. Hmm. It's clear to attitude girl. Okay. So uniform motion, non-uniform motion we discussed. So if you're moving at equal distances in equal intervals of time, then that motion is called uniform motion. Otherwise, it's called non-uniform motion. Hi Pradeep. Hello, how are you? Okay. So I can give you an example for that also. Let's say this is Raghav. Okay. And this is Sweta. Okay. Raghav and Sweta. So Raghav's running from his house. He's running all the way to Sweta's house. So initially he runs very fast. So he covers 10 meters in 20 seconds. Okay. And then he slows down. Now he covers the next 5 meters in 5 seconds. Then he covers the next 10 meters in 30 seconds because he's very tired. Okay. The next 10 meters he covers in 40 seconds because he's very tired. Okay. So is this motion uniform motion or non-uniform motion? Quickly let me know. Is this uniform motion or non-uniform motion? Yes. Tell me. Yes, is it uniform motion or non-uniform motion? Mm-hmm. It is non-uniform motion. Why do you say that? It's because every 10 meters he does not take the same amount of time. So he covers different distances in different amounts of time. So this is non-uniform motion. Now let's make this uniform motion. To make this uniform motion, what should you do? To make this uniform motion, every 10 meters he should take, let's say, 5 seconds. 5 seconds, yeah. So every 10 meters, if he covers in 5 seconds, then that is called uniform motion. Okay? So that's the difference between uniform motion and non-uniform motion. Is that clear? Clear all of you? Yes, no? Oh, now this. So, these are the equations of motion. Okay? Whenever there is constant acceleration and whenever acceleration is not constant. Okay? What does it mean to have constant acceleration? Constant acceleration means it covers equal distance in equal intervals of time with equal speed. Okay? Speed is not increasing. What is the formula for acceleration? V minus u by t. Okay? So if v minus u is not changing, which means initial and final velocity is the same, then acceleration is constant. So if you're driving, okay, and the speed or velocity on the speedometer is 30, okay, it's showing 30. For half an hour also it's 30, okay. Sorry students. After 50 minutes also it's 30. After 2 hours also it's 30. That means you're going with the same speed, okay. So when you're going with the same speed, there is no increase in or decrease in speed, which means there is no acceleration. Okay. So when there's uniform acceleration, these are the equations of motions you use. But if the acceleration is not constant. For example, in the first 30 minutes, you drive at a speed of 70. Then you increase, you drive at 100. Then you drive at 120. Then you reduce, you drive at 30. So in that case, acceleration is keeping on increasing and decreasing. So acceleration is not uniform. Okay. So in that case, you will use these equations. Those are using the concepts of differentiation and integration. Okay. Yes. Hi everybody. Hi Lavanya. Hi Sunita. Hi Yamuna. Okay. Is this clear? Yeah, we use the different formulas. Now we will derive them. Okay. So we will derive all of them. So these derivations, if you're looking in terms of KCET, you don't want them. But if you're for your not competitive exam. For your first PU or second PU, you definitely need them, right? So we will just quickly go through them. Okay, let's do that. What is happening here? Okay, so yeah, the equations of motion. Let's do it. So first thing, we are going to use the general method. So what is the first equation of motion? V is equal to u plus at. Yeah, I didn't discuss it here because I'm going to discuss each of them individually. So first equation of motion is V is equal to u plus at. So what is V? V is the final velocity. Okay. V is the final velocity. U is what? U is the initial velocity. A is acceleration and T is time. Okay. Now, what is the definition by definition of acceleration? Already we know that A is equal to V minus U by T. Okay. So, acceleration is velocity by change in velocity by time. So, this is basically V minus U by T. Now, very simple. I'm just simply going to cross multiply. So, what will this become? AT is equal to V minus U. And then I take U to the other side. So, V is equal to U plus 8. That's all. That is the first equation of motion in 2 steps. Okay, but if you're for your PU or your FA1, they will ask you, okay, to either use graphical method or derive it and all that. General method they don't usually ask. But yeah, it's good to learn that. Maybe for 1 mark and 2 marks, they can ask you that. Okay. Next formula, S is equal to ut plus half at square. So what is S here? S here stands for distance. Okay, sorry, displacement. Okay, displacement. U as usual is initial velocity, T is time, and A is acceleration. Okay. So displacement is what? What is the formula for displacement? Yes, it is. So here what I will actually take is, I'll take the formula for average velocity. Okay. So velocity average is total displacement by total time. Yeah. Average velocity is total displacement by total time. So from this, displacement is V average into time. So displacement I'll represent by S. V average is what? The total velocity. Total velocity is U plus V by 2 into time. Okay, do you all agree? Yeah, total velocity is U plus V by 2 into time. Now here I'm going to do a small, shortcut method. Not a shortcut, this is the method. U plus, what is V? From my equation of motion, I already know V is what? U plus at. Yeah, U plus at. So instead of V, I will write it as U plus at by 2 into T. Okay. Now let's open the brackets. So S is equal to 2U plus at by 2 into 2. So S is equal to, I multiply 2 inside, ut plus at square by 2. Can I say that? Yeah. How did I do that? What I did is, I multiplied 2u by 2 plus at by 2 into t. And then I multiply t inside. 2 and 2 will cancel. So you will get S is equal to ut plus half at square. Okay. Is this clear to all of you? Any doubts here? Any doubts? Hi, it's Chetan. Welcome to the lesson. Yes. Any doubts here? Yeah. So S is equal to ut plus half at squared, second equation of motion. Now, third equation of motion is what? V square is equal to u square plus 2as. How will I do that? What is v square? It is velocity square. What is u square? Final velocity, initial velocity square, and then 2as is 2 into acceleration into s is displacement. Okay, s is not second, s is displacement. So from first equation of motion, what do we have? So from the first equation of motion, what is it? We have v is equal to u plus at. Huh? First equation of motion, v is equal to u plus at. Now let us square it. Okay, squaring it, this becomes v square is equal to u square plus whole square. V square is equal to u plus at square. Okay, so v square is equal to u square plus a square t square plus 2u at a plus b the whole square. I'm just opening the brackets. Okay, now what I'm going to do is, once I'm chatka matka, I'll just multiply and divide 2 here. Okay, multiplying and dividing 2 there. So what happens? This becomes v square is equal to u square plus. Now in both of these, I'll take the common terms outside. So what are the common terms? 2 is common for both. A is common for both. So I'll take that outside. T is also common. So let T be there. Okay, I'm not taking it now. So what remains here? A t square by 2 plus ut, right? Yeah. Plus ut. Okay. Now, v square is equal to u square plus 2a into, I'll just change the order, ut plus half at square. What is ut plus half at square? Newton's second law of motion, it is s. So this is s. So what will the equation be now? V square is equal to u square plus 2as. Okay? Yeah? So this is from the second equation of motion that I get this. Okay? Yes, no? Okay? No response in the chat. Today there's nobody in. Everybody's sleeping in class. Okay. Next is the distance traveled in nth second. So imagine, you are moving from one point to another. Okay? You are moving from A to B. Okay? So you reach a point where, let's say time here is n minus 1 second and time here is n seconds. After some time it will be n plus 1, n plus 2. It just goes on like that. Okay? And let's say the total distance travel is Sn. Then here the total distance travel from A to the midpoint will be Sn minus 1. Total is Sn. The half will be Sn minus 1. Okay? So the distance travel, okay, let's take this point as A. Okay? So the distance traveled in nth second. Okay? So in nth second, the distance traveled is equal to AB. Okay? Now if O is the starting point, then AB will be equal to OB minus OA. Do you agree? AB will be OB minus OA. So Sn plus, so Snth second. Okay. in the snth second, it will be Sn minus 1. Okay. So this is going to be equal to, what is Sn? U plus half at square. So this will be Un plus half an square minus Un minus 1 plus half an minus 1 square. Okay. So this will be equal to Sn is equal to Un, and Un minus 1, they will cancel. So you will get Un plus, I will just multiply and divide 2 and 2 for an minus half a. So this will be equal to u plus half a 2n minus 1. Okay. So this derivation, I don't know if I don't think you need it for your PU syllabus. So in PU, I've only seen questions where they ask you, the first three equations of motion. Okay. Bharati is sleepy. Bharati sleeps at 9:50. Okay, Bharati, from next week onwards, I'll take classes early then. Okay. Yes, I had dinner, Sanjay. Bharati is going to sleep. Okay. Sanjay, as always, is there in class. Okay, students, so these are the 4 equations of motion. Okay. Now we will look at some questions related to these equations of motion. Okay. Are you all students who sleep early and wake up early? Or you sleep early and wake up late? Let me know in the chats. What kind of a student are you? You like to sleep early or you like to sleep late? I thought, your generation will be all students who are sitting up late night. No? All of you sleep early? Mm-hmm. You all, okay? You all like the video? Yes? Like done? Subscription done? Share done? Okay? Okay. So before we move on to this question, we'll just take a 10-minute break. Okay? I'll just be back. Okay? So you can all quickly go eat and come. We'll continue with questions based on this. Okay? So we'll do all KCET past year paper questions based on this chapter once I'm back. Okay? Hello, all of you. Am I visible? Yes, I think I'm visible. Let's quickly solve this question. This is a very interesting question. I've already done this before in classes, but it's a very nice question. So I want to do it once again in KCT class also. Okay. A particle moves along a circular path of radius r. Okay. So let's say you have a circle. Let's say you have a circle. And the circle has a radius of r. Okay. So my circle looks like a laddu, but it's actually a circle. It has a radius of r. So if I take this point A, this point B, C, and D. Find the distance traveled by the particle as it moves from A to B. Okay, so what will the distance be from A to B? This curved path is the distance. So what will it be from A to B? It will be, it's basically 1 by 4th of a circle, isn't it? If this is the whole circle, from A to B is 1 by 4th of a circle. So this is going to be 1 by 4 into the whole circumference of the circle is 2 pi r. Okay, so what will this be? 4 and 2 will cancel. So this will be pi r by 2. Yeah. Okay. Next, from A to C. So from A to C, it's basically this much. Okay. So from A to C, it will be how much? From A to C, it's basically half of a circle. So half into 2 pi r, which is the radius of the circle. So this is going to be equal to pi r. Next is from A to D. Okay, so let's do that. So from A to D will be A. Okay, I'll use a different color. A to B to C and then to D. The blue part from A to D. So that is basically 3 by 4th of a circle. 4 and 2 will cancel. So this will be 3 2s are 6. So 3 by 2 pi r. Okay. So it will be 3 by 2 pi r. Next, when it completes one full revolution. So when it completes one full revolution, what will it be? Which color? I'll take orange. Yeah. So from A, it will go to B, it will go to C, it will go to D, and then back to A. So one full revolution, the answer is obviously the circumference of a circle. So it will be 2 pi r. Okay. Next question. Also find the magnitude of the displacement in each of the above case. Find the magnitude in each magnitude of displacement in each of the above case. How do I find the magnitude of displacement? So it's basically how much? Quickly tell me. Yes, 0, because I started at point A, I came back to point A. So the total displacement should be 0. Exactly, very good. Now I can mathematically do it as well. So what I should do is, no, I don't have to mathematically do it. I can just say it's 0. Okay. Now to find out the distance, find out the value of r, I can actually do something. What can I do? A, B, I can find out the total displacement, the value of the total displacement. So what should I do? From A to B, it will be this much. B to C will be this. C to D will be this. D to A will be this. But I don't have to do that. The total displacement is going to be 0. Okay? Okay, so there's one more part of the question where they ask you to find displacement in each case. That we can do by doing this. So if this is R, this will also be R. What will this be? Pythagoras theorem, R square plus R square. So this will be square root of R square plus R square will be square root of, okay, R square plus R square root is going to be equal to square root of 2R square is going to be equal to square root of 2R. So this is square root of 2R. Okay. Okay. So now, no, I don't think you'll understand if I draw any more on this figure. Let me draw the figure once again. Okay. Yeah. So this is A. This is B. This is C. This is D. Okay. This is the center. This is R. Okay. So the shortest possible path from A to B is obviously root 2 of R. Now from A to C, what is the shortest possible path? Isn't it going to be this one? So it will be R plus R, it will be 2R. Now from A to D, what will the shortest possible path be? It will be this, which is the same as root 2 of R. Okay? So for one complete revolution, it's going to be 0. Okay? Okay. Now, equations of motions can be modified when they are written under gravity. How can you do that? Equations of motion under gravity. Yeah, thank you, thank you. I can talk in little Kannada, not fluently, dear. X minus x is equal to 0. Why x minus x 0? Are you talking about the total displacement, Sanjay? I think my live chat is stuck. 1 second. Thank you. Okay, yeah, now I can hear. Okay, yeah. Okay, so equations of motion under gravity. So what we're going to do is we're simply going to modify all the equations of motion that we learned with respect to gravity. Okay, so what are the equations of motion? So first thing that you need to know is, okay, imagine if this is the earth. Okay, this is the earth and there's a height, okay, some height edge. So if there's a ball that's coming down, okay, if there's a ball that's coming down, it's coming down initially. Imagine this is a 10-storied building. Okay, you are on top of a 10-storied building. Okay, so on top, u is equal to 0. So you are holding the ball. So you go, your friend's apartment or your apartment, whichever apartment, or your school or whatever. Please don't do this at home. Okay, so you're on the 10th floor. You're holding a ball. Okay, you're holding a ball. When you're holding the ball, what is the velocity of the ball? It's at rest. It's in your hand. So it is 0. The moment you drop it, what happens? It falls down with an acceleration and the value of acceleration is going to be plus g. Why plus g? Because it is falling down to earth. Okay? It is falling down towards earth. So when something is falling to earth, the gravity will be plus g. And the value is going to be equal to 9.8 meter per second square. Okay. Now, one more case. Same thing. Earth. The same building. But this time, you are going to throw the ball up. Okay. So, you are going to throw the ball up. So, initially, you're holding the ball. You're throwing it up. So, here, again, initial velocity is 0. So, you're throwing it against gravity. So, it will be, acceleration will be minus g. Acceleration will be minus 9.8 meter per second square. And once the ball reaches up, it stays there and then comes down. For 1 second, it stays there. So the final velocity on top will be 0. Okay. Initial velocity need not be 0 because you are throwing it, no? Okay. So initial velocity need not be 0. Is this clear? Yes. So you are throwing the ball up. Okay. Now, acceleration is gravity. Yeah. And the displacement is the maximum height, which is h. So what I will do is I will substitute this on all my equations of motion. So what is the first equation of motion? V is equal to u plus at. So this will become V is equal to u plus gt. Next, h displacement is equal to ut plus half at square. So this instead of displacement, I will write h. H is equal to ut plus half at square. Next, v square is equal to u square plus 2 as will become 2gh. Okay. So these are my different equations of motion. So here instead of this, I'll write it here itself. U plus gt. Now if something is falling down, then what are the equations of motion? So here acceleration will be minus gravity. Displacement will be h itself. So the formulas will become V is equal to u minus gt. H is equal to ut minus half gt square. V square is equal to u square minus 2gh. Okay? Yes. So these are the different equations of motion when it's influenced by gravity. Is that clear? Okay. Now we can do questions based on that. So before we do questions, I want to finish all the portions and then we will do the questions. Is it clear to all of you? Yes. Equations of motion, general method, equations of motion under gravity. Okay. Now we will look at equations of motion using graph. So graph is, what is a graph? A graph is something that is drawn to give you the relationship between two quantities. Now, okay. On the x-axis, it's always the independent variable. Now, on the y-axis, it's always the dependent variable. So if something depends on something, it should be on the y-axis. If it's independent, it should be on the x-axis. So if there's a line like this, what does that mean? If there's a line like this, what does that mean? It means that whatever is there on the y-axis is a constant. Okay. So imagine y-axis has values. Imagine it has values 2, 4, 6 and it goes on. So according to this graph, y is always 4. Okay, according to this graph, y is equal to 4. Now if I don't put the numbers, what can I say? I can say y is a constant. Okay. And what about x? What about x? X is first 1, then it's 2, then it's 3, then it's 4. So x is increasing. So a graph like this means y is a constant and x is increasing. Okay? Now, if I draw a line like this, what does that mean? So that means, let's say 2, 4, 6. Here also I'll put 2, 4, 6. So when x is 2, y is 2, x is 4, y is 4, x is 6, y is 6. So you can see every time whenever x increases, y also increases. Yes, that's the graph. X increases, y also increases. Okay? Yes. So that's a slope graph like this. It means that. Now, next. Next graph. If you have a graph like this, okay? So let's say this is 2, 4, 6. 2, 4, 6. So here also x and y, they both increase, but the increase is slow. Okay, so you can see it's slowly increasing. Okay, so x increases, but then y increases slowly with respect to x. Okay, what is the next graph? What is the next graph? What is the next graph? If it's like this, what does that mean? Very easy. 2, 4, 6. So when x is 2, y is 4, x is 4, y is 4, 6 and 2. So when x increases, y is decreasing. A slope like this means one increases, other decreases, inversely proportional. So a slope like this means directly proportional. Downward slope is inversely proportional. Now here also I can have a graph the opposite like this. So what will that mean? X increases, y increases fast. Okay? Yeah. Next is, what does slope mean? What does slope mean? Slope means what? So if you have an x-axis, y-axis, this is the slope. Okay? Now, slope of this graph is given by slope. Slope of this graph is given by tan theta. Okay, sometimes slope is represented by tan theta, and that is going to be equal to change in y divided by change in x. What is change in y by change in x? Change in y means y2 minus y1, the whole divided by x2 minus x1. Okay, so change in y divided by change in x means y2 minus y1 by x2 minus x1. I'll show you with an example. So let's say this is 2. I always put 2, 4, 6. No, it's easy as numbers. That's why. Let's just put this 1, 2, 3. Okay. So this coordinate is basically 2, 4. And this is 1, 2. Okay. So slope will be, this is basically y2, x2. This is y1, x1. This one. So this is 2 minus 1 divided by 4 minus 2. 2 minus 1 is 1, 1 by 2. So the slope is 1 by 2. Okay. So tan theta or slope is basically change in y-axis coordinates divided by change in x-axis coordinates. Now what is basically slope? So if this is a graph and this is the line. So the angle at which the line is, that is the slope. So tan theta basically means tan of this angle. Okay, this angle is theta. So tan of this angle will also give you slope. Alright. Now, sometimes depending on what is on the x-axis and y-axis, you get different quantities as slope. Okay. So for example, let's see. If you have velocity and time, okay, and you have a line like this, okay. So here, what does the slope mean? Slope means change in velocity by time. What is change in velocity by time? Acceleration. So slope is acceleration. Okay. Next is distance into time. If I have a line like this, what is the slope here? Change in distance by change in time. What is distance by time? Yes, velocity. So the slope of a velocity time graph gives acceleration. The slope of a distance time graph gives velocity. Okay. And what is the general formula for slope? Slope, it's also represented by the alphabet y. Okay. Slope is also represented by the alphabet y is equal to tan theta, which is equal to del y by del x, which is basically y2 minus y1 by x2 minus x1. Okay. All right. Hi Antox. Hi Kirtan. Raksh. Hi. This is live. Okay. Not just live video. This is live only. Hi. Hi. Okay. Is this clear to all of you? Okay. Now, sometimes the area under the curve also represents so many different things, right? Yeah. Thank you. Hi Tejas. Welcome to the lesson. It's almost halfway through, but still welcome to the lesson. Yeah. So area under the curve. So if you have an x-axis and a y-axis, okay, and let's say this is the graph. If I take the area under the curve, depending on whatever is on the x-axis and the y-axis, I get the value. I mean, I'll tell you. I'll tell you in a little more better manner. So imagine on the x-axis you have time, okay, and the y-axis you have velocity. So what will the area under the graph be? It's a rectangle. So the area under the graph will be velocity into time. What is velocity into time? Yes, displacement. So if you have a velocity time graph, area under the graph gives you displacement. Now sometimes it could be a triangle like this, velocity and time. So now area under the graph is basically half into velocity into time. So this is basically displacement. Okay. Now imagine I change the axis. I change the axis and I make it acceleration and time. So what is acceleration into time? Yes, it is change in velocity. Yeah. Acceleration is v minus u by t, which is change in velocity by t. So change in velocity is basically acceleration into time. So the area under the graph for a velocity time graph gives displacement. The area under graph for acceleration time graph gives change in velocity. Okay, you have to keep that in mind. Now we will derive the equations of motion. This is what is usually asked in your PU exams, right? By graphical method, you will be asked to draw the graph also. Okay. So this is what is going to be asked in your PU exam. So how will you draw the graph? I'll just replicate the graph once for you. So first thing you will draw the, oh my god, I can't, okay, yeah. You will draw the x-axis and the y-axis. X-axis and y-axis. On the x-axis, you will draw time. On the y-axis, you will draw velocity. Now, imagine from a point A, okay, you are driving a car. Some of you might be thinking, why I'm so upset with a car. That's the only example that's coming to my head. I'm not a very creative person, students. I'm a very dry person. Okay. So if A is you're driving a car. Initially, the car is at rest. So that is why velocity is 0. Along the y-axis, anything is 0, right? And then I drive it till point B. Okay. So I drive it for some time. T. Now, what is this? This much is my initial velocity u. Now, this full thing is my final velocity v. Okay. Why? Why do I say that? Some of you might not understand that. See, if this value is 6, then my final velocity is 6, right? This whole thing. If this value is 4, then my initial velocity is 4. So from there to there, from v to down, it's v. Okay? And then I can just draw this. So this is my graph. That's all that I need in my graph. Okay, I will draw a line like this also. Okay, same thing I've drawn here. From here, I draw the line. Okay, this much is v, this much is u. All right, now let's do it. Let's derive. Let's do the derivation. So I'm going to write down AB to be BC by, AB will be BC by AC. Okay. Slope. This is also another formula for slope. So we know that the slope of a velocity time graph is what? You already know that. Slope of velocity time graph is equal to acceleration. Yeah. Slope of a velocity time graph is equal to acceleration. So A is equal to the slope of AB. Slope of AB is basically BC by AC. Now what is BC? BC is V minus U. Yeah, B is V. So BC is V minus U. AC is time T. So this is basically A is equal to V minus U by T. AT is equal to V minus U. AT plus U is equal to V. Okay. Now this is very important with respect to diagram. Diagram is very important. So see, this much is V minus U. That's what I've done. That's all. Okay. So this is the first equation of motion. Okay. Yeah. Now next is the equation of motion by graphical method for second one. So here what I'm going to do is I'm going to divide this into two boxes. Hey, what happened there? Too bright. Hmm. Okay. Okay. I just wanted you to see the difference. Okay. That's why I did all that coloring. Sanjay says I teach physics creatively. It's the first time, Sanjay, someone's calling me creative. I'm not at all creative. Okay. Hi, Minu. Minu or Minu? What's your name? I think since it's double N, it should be Minu. Hi, Minu. Hi, Tejas. Okay. Okay. So now what we're going to do, we're going to use graphical method to find out the second equation of motion. Okay. So first thing, as usual, area under the graph. Area under the velocity time graph. What does area under velocity time graph give? You should tell me now. Very good. It gives displacement. So let's find out the full area under the graph. So it's a triangle and a rectangle. So we have to add the area of triangle plus area of rectangle. So S is equal to half into AC times BC plus OD times OA. Okay? Or if you look in the figure, AC, BC, base into height, and then side into side for the rectangle. So this is basically half into AC is T, BC is V minus U plus T into U. So this is basically half T. V minus U can be written as V minus U can be written as AT. Yes, plus TU. So this is basically half AT square plus U2. So now from this I have S is equal to UT plus half AT square. Okay. Now quickly, next, last one. Equation of motion by graphical method, the last one. Here also I'm going to take the area under the graph, but here I'm going to take it as one full block. I mean, like this. So what is the shape called? Oh God. I shouldn't have done that. Okay. So I'm going to take the whole thing. So, so this is like a trapezoid. Okay. So for a trapezoid, the area is given by half A plus B into H. Okay. Half into side plus side into H. Now what is the side and side? The two parallel sides. Okay. So A is the length of one parallel side. So B is the length of the other parallel side. H is the perpendicular height. Okay. So this is basically going to be equal to half times the parallel sides are OA and BD. Yeah. OA plus BD into the line between parallel line is AC. Yeah, it'll end before 12, dear. Don't worry. Okay, it'll end before 12, Sanjay. At what time did yesterday's class end? Okay, yeah. So this is going to be equal to half OA is U, BD is V, AC is T. So this is basically S is equal to half U plus V to 2. So 2 into S. I'll multiply S. This will be U plus V times T. Okay. Now what I'm going to do is, I'm going to do T. Instead of T, I'll write it as V minus U by A, first law. Okay. So now what do I have? Now what I have is A plus B into A minus B. So this is basically A square minus B square, the whole divided by A. So 2AS is equal to V square minus VU square. Okay. So rearranging this, I can write it as V square minus U square is equal to, V square is equal to U square plus 2AS. Okay. Yes. Oh, my is not clear. Now is it visible? Okay. Okay. So with this much, shall we do some questions? Yes. We'll do some questions based on this. Okay. So let's look at some questions. So these are all previous year KCET questions. I haven't discussed differentiation, but let's do some questions before that. Okay. So the question is, two stones begin to fall from rest from the same height. Okay. So there are two stones. They're falling from the same height. With the second stone starting to fall delta t seconds after the first falls. Okay. We have two stones. The first one falls. After delta t seconds, the second one falls. The distance of separation between the two stones become h. T0 seconds after the first stone starts motion. Then T0 is, I have to find out the difference. Okay. Is that clear? Yeah. Okay. So let me write that down. Okay. So the first stone falls after T0 seconds. So the distance, okay, distance S is equal to UT plus half AT square, right? Yeah. But here it's a stone that's freely falling and it's falling down. So I should use the equation of gravity, which is UT plus half GT square. Okay. Now this U is 0 because initially the stones are at rest. So this is 0. So now the equation will be S is equal to half GT square. Okay. It's going to be S is equal to half GT square. Now what is the time? It is T naught. So it's going to be equal to S is equal to half GT naught square. Okay. So this is distance fallen by the first stone. Now for the first stone, this is the distance. Now let's do the same thing for the second stone. Second stone, I'll take it as S2. So S2 will be how much? half g. Now what will the difference in time be? There is a small time difference of delta t. So t minus delta t square. Okay. So this is the distance fallen by second stone. Now what is the separation? Obviously separation should be S2. I don't need S2S. Separation should be S2 minus S1. So this is basically half GT naught square minus half G T naught minus delta T square. So this is going to be equal to, if I open the brackets, it will be half G is common in both. So half G I'll take outside. Okay. If I take half G outside, then this will be T naught square minus T naught minus minus T naught square del T square plus 2 T naught del T. Okay. So this cancels. So this will be half G into 2 T naught del T minus del T square. Okay. 2 T naught del T minus del T square. So this is equal to what? I'll multiply 2 inside. So G times T naught del T minus half del T square. Okay. So I have to find out the expression for T naught. This is quite a long question. Okay. But it's not complicated. It's just long. Now, H is equal to half G delta T square. What can I do next? I can multiply T naught into G. I can do okay. Now let's just solve this for T naught. Okay, let's just solve it for T naught. Solving for T naught. Okay, so for solving for T naught, what I will do is I will write the equation first. So H is equal to G T naught delta T minus half delta T square. Okay. So from this, I will write T naught delta T is equal to H by G plus half delta T square. Okay. So from this, T naught will be equal to H divided by G delta T plus half delta T. Other two will cancel. So T naught will be H by G delta T by half. Now what will the option be? It's going to be H by delta T. So option C. How many of you got option C? It's quite long, no? Yesterday I left class at 12:15. No, I left class before that. Was it at 12:15? Oh my god. Yesterday Sanjay slept at 1:30 after doing some PYQs also. Wonderful, Sanjay. Good. All that hard work will reflect when you write your KCT exam, okay? So when you write a KCT exam, you will get to know, that everything that you did was for good. Okay? So is this question clear? Yes. So this is a question from motion in a straight line. Okay? Okay. Next question. A body is moving along a straight line with initial velocity v0. Okay? The body is moving in a straight line with initial velocity v0. Its acceleration a is constant. Okay? Now, after t seconds, its velocity becomes v. Okay? So, average velocity of the body in the given time interval is what we have to find out. Are you all ready to do it? Yes. So, first we will use the equation of motion that we know. So, let's use the equation of motion. So, first equation of motion will be v square is equal to u square plus 2as. So, from this I can rearrange. I will get s is equal to v square minus u square divided by 2a. Okay. Now, average velocity will be what? Average velocity will be total distance by total time. Okay. Average velocity is total distance by total time. So, let's say it's s by t. Okay. Total distance by total time, s by t. Okay. Now what will we do? Let us do substitution. So v bar is equal to s is what? V square minus u square, the whole divided by 2a, the whole divided by t. So this will become v square minus u square, the whole divided by 2at. Okay. So v average is basically v square minus v naught square. V square minus v naught square, the whole divided by 2at. Okay. Is there an equation like that in the options? Let's check. V square minus, okay, yes, there is. Option D. Okay. Are you all getting option D? How many of you are getting option D? Option D, option D. You're getting option D? Yes? Okay. Good. Okay. Next question. The displacement x in meters of a particle of mass m in kilogram moving in one dimension under the action of a force is related to time t in seconds by t is equal to root x plus 3. Okay. The displacement of the particle when its velocity is 0 will be. Okay. So you have to find out the displacement of the particle when its velocity will be 0. Okay. Okay. So, yeah, Sanjay got D. Very good, Sanjay. Okay. Very good. So, let's do this. Okay. So, T is equal to root x plus 3. Yeah. T is equal to root x plus 3. That's given to you in the question. So, root x will be T minus 3. Okay. So, now x is equal to T minus 3 the whole square. Okay. So, x is equal to T minus 3 the whole square. So, from this, x is equal to T square minus 60 plus 9. t square minus 6t plus 9. Now what is velocity? Velocity is change in displacement by change in time. So in terms of differentiation, it's dx by dt. What is x? d by dt of t square minus 6t plus 9. Okay, so this is basically 2t minus 6. Okay, so v is equal to 2t minus 6. Now, when v is equal to 0, what does it become? When v is equal to 0, it will become 2t minus 6 is equal to 0. So, 2t is equal to 6. T is equal to 6 by 2, which is 3. 3 seconds. Okay? So, x will be equal to, x will be equal to 2 into 3 square minus 6. So, which is basically 2 into 3 square minus 6. No. I'll use it in the other formula. X is going to be equal to 3 square minus 6 into 3 plus 9. So, this will be 0. Okay? Yes. Is that clear? Easy, no? So, some of you might be wondering what I did because I didn't explain differentiation in this chapter. So, now quickly I'll just explain differentiation also to you. For those of you who know, you can just, fast forward this part, but for the others. Okay? Students, if you have a term, let's say x, okay? The differential of x is given by dx by dt, okay? Now, dx by dt or the differential of x is given by, so what you will do is you will take x, okay, f3 minus 1, which is 3x square, okay? So, differential x raised to n dx is basically n into x raised to n minus 1. This is how you do differentiation. Okay, so that is what I've done in this question also. Okay, yes. Now, how will I differentiate 3x square? So, d by dt of 3x square will be equal to 3 into 2, 6x, 2 minus 1. So, it's basically 6x. Now, how will you differentiate 6x? d by dt of 6x is basically going to be 6x will be 6x raised to 1 minus 1, which is basically 6 into x raised to 0. So, 6. So, this is how you do differentiation. Okay? Yes. Is this clear? Okay, let's quickly move on to the next question. For a body moving along a straight line, the following VT graph is obtained. According to the graph, the displacement during first part, uniform acceleration is greater than uniform motion. Uniform acceleration is less than uniform motion. Uniform acceleration is equal to uniform motion. Uniform motion is 0. Okay. So, which part represents uniform acceleration? Obviously, this part, because velocity is increasing with time. And which part shows uniform motion? It will be this part. So, which is less? Uniform acceleration. So, the answer will be option B. Uniform acceleration is less than uniform motion. Very easy question. Come on. Okay. At a metro station, a girl walks up a stationary escalator in 20 seconds. If she remains on the escalator, then the escalator takes her up in 30 seconds. The time taken by her to walk up on the moving escalator will be. That is the question. Okay. So let's say the velocity of the girl is, it's basically the speed of the girl walking. Okay. Speed of the walking girl. Now, V of escalator will be the speed of uh, escalator. Okay. Now, when the girl walks up on the stationary escalator, she will take 20 seconds. Okay. So, the distance will be V of girl into 20 seconds when the girl walks up the stationary escalator. Okay. When the escalator alone moves, the girl does not do any work and she takes 30 seconds. So, in this case, only the escalator speed is taken. So, this will take 30 seconds. So, now the girl is on the escalator. Escalator is moving. She is not moving. Okay. Yes. Now, third case is what? When the girl walks up the moving escalator, the escalator is moving, girl is also moving. So then the distance will be what? Velocity of the girl plus velocity of the escalator into time taken. Okay. So now from this we know velocity of the girl is equal to d by 20. Okay. From this, velocity of the escalator is what? D by 30. Okay. So let's substitute both that here. So here we will get D is equal to D by 20 plus D by 30 into T. Okay. So from that, we will just write 1 by 20 plus 1 by 30 into T is equal to 1. I cancel all the D's because it's there on both the sides. I cancel the D's. Okay. Now 1 by 20 plus 1 by 30 will be what? I'll take the LCM by 60. So 3, 4, 5. It will be 5 by 60. So 5 by 60 into T is equal to 1. So T is equal to 60 by 50. Sorry, not 55. Okay. How stupid. 5. 60 by 5. So this is basically 1 by, no, not 1 by 12, 12 by 1, no, 12 seconds. So this is 12 seconds. Option C. Okay. Are you all getting option C? I take classes from home, Sanjay. Okay. 0. 0 was for the previous question. Okay, yeah. Yes. 12 seconds. 6. Okay. Is this fine? Shall we do 2 more questions and then wind up? Yeah. Okay. Next question. The car is moving with a velocity of 20 meters per second. It stopped at a distance of 40 meters. If the same car is traveling at double the velocity, the distance traveled by it for some retardation is. Okay, let's do it. So initial velocity is given, it's 20. Okay. Final velocity is not given, distance is given. So S is 40. We have to find out the deceleration. So what equation of motion I can use? I can use V square is equal to U square plus 2AS. Yes. So V square So let's say velocity is 0. Okay. So 0 square minus u square is equal to 2as. Okay. 0 square minus u square is equal to 2as. How much is u? 0 square minus 20 square is equal to 2a into 4. Now it's very easy, no? Minus 20 square is what? 400. Minus 20 square is 400. So minus 400 is equal to 80a. Okay. So a is equal to minus 400 by 80, which is minus 5 meter per second square. Is there an option? Okay, that's not the answer. That's not the end. Okay, so acceleration is minus 5 meter per second square. Now we have to find out the increased velocity. So in the question it's given that the velocity becomes double. So u dash is equal to 2u. Okay, so which is 40 meters per second. That's given to us in the question. Okay, same car is traveling at double the velocity. So u dash is the same car traveling at double velocity. So 2u is also 40. Okay, 2u is 40. Now let's do the same equation again. So you have 0 square minus 40 square is equal to, how much will the acceleration now I know is equal to minus 2 into 5 into s. Okay. Minus 40 square will be 1600. So minus 1600 is equal to minus 10s. So s will be 160 meters. Okay. Yeah, we have an option. Very good. So the answer is going to be option C. Okay. Yes. Is this fine? All right. Okay, okay. Done. Let's look at the next question. Oh, that's all. Okay, that was the last question. Fine, fine. Okay. So done. So that those are some questions on KCET from chapter motion in a straight line. So motion in a straight line you have to do even more, but this is like a basic understanding of motion in a straight line. Okay. So I hope this was all clear to all of you. Yes. Okay. So we haven't discussed differentiation. That we will discuss soon, or if you watch the previous videos, it's there, but in this KCET series also we will discuss it. Okay. So I will I will come again with another class. So next week probably we'll be doing second PU. So I will do classes alternately. So 1 week first PU and then the next week second PU, and then alternate classes. Okay. Okay. So I'll see you all in another lesson. Till then, bye bye.